So firstly, I want to say that thank you so much for this great session. I really enjoyed it. So I just wanted to ask, give an example of a paradox, and can you just in simple words tell me how, which kind of line of thinking do you adopt in order to solve these paradoxes? I mean, beyond these teachings, of course, you do a lot of research on these. So I want to know the line of thinking you adopt. Can you just shortly say that in simple words?
Okay, so I mostly want to do more research on applied math, not quite pure math, but I'll still give the best answer that I possibly can.
Okay.
So, in terms of paradoxes, well, there are a lot of paradoxes that you've just seen concerning, well, the value of a number where two different limits are present. And there are also lots of paradoxes concerning numbers that can't even exist, like -1. But more than that, I think there were many interesting conjectures that are extremely simple to state, but extremely hard to resolve. Like, for example, Fermat made a conjecture all the way back in 1637, where he said, we have a plus b equals c. That's solved easily. A squared plus b squared equals c squared. Pythagoras solved that a very long time ago. But there is no solution to a cubed plus b cubed equals c cubed for any integer. Neither is there a solution for a to the fourth plus b to the fourth equals c to the fourth for any integer. And in general, there's no solution for a to the n plus b to the n equals c to the n for any integer. This is extremely simple to state, but to solve it requires almost 21st century math. So, this was solved finally in 1995 by a man named Andrew Wallace from the UK. But obviously that's not the full story. There were hundreds of mathematicians working on it. Some of the most famous ones included Dirichlet, Lebezieux, I'm probably not pronouncing either of those two correctly. Euler worked on it, so did Gauss, but none of them could solve it. So there were partial proofs for 3, 4, 5, 7, and 11 came out, and with the advent of computers, we managed to get it up to n is about 4 million, but we never could prove it for all integers until some extremely difficult math that I do not understand came out around 1950. Has something or the other to do with elliptic curves and modularity, but I know. So this theory, seemingly completely unconnected to this problem, managed to solve it pretty easily. Well, not easily at all, but still relatively easily. So after almost 350 years of math, this extremely simple conjecture, which even a 7th grader could understand, was solved. There were even simpler ones that a 3rd grader could understand that still haven't been solved. Like, can every even number be expressed as the sum of 2 primes? Like 76 over here can be expressed as what? Well, let's try a simple example. Like, for example, 37 and 41 add up to 88, so 88 is an example of a number that can be expressed this way, but can any number be expressed this way? So like 3, 4, 5, 8. It would be extremely tedious to figure this out, and we figured it out for lots of numbers, but no one had proved it for the entire set of natural numbers. And in a similar style, we can ask, are we able to see if this sequence converges to 1 for any number? So let's say we take some number n at the start. If it's odd, we multiply it by 3 and subtract 1. And if it's even, we have it. And then we keep going. Well, if this is even now, well, it has to be. Then we have it. And if this is odd or even, then it can go 2 ways and so on and so forth. So for every integer we've tested, this converges eventually after some long number of transformations to 1. But we don't know if this is true for the entire natural numbers. So a lot of these paradoxes are completely in number theory, and we haven't even figured out a use for some of them yet, but I mean, they're extremely fascinating to think about, especially because they're so simple. Because a lot of the unsolved problems are extremely hard to understand, let alone make steps towards These are like abnormal for how simple they are to state, but how hard they are to solve.
Okay, thank you so much. Thanks a lot, seriously.
No problem.